Good afternoon, integrated topic students. Ms. Codner here for the lessons of May the 16th, 17th, 18th, and 19th. Since there's so many days, we're doing that HSA breakdown, so we have special schedules. So we're revisiting what we left off last on the quadratic functions. So this was a little bit of notes that we took. The quadratic function, which is ax squared plus bx plus c, where a, b, and c represents numbers. And my a cannot equal 0. So if you remember that a is my leading coefficient, so it can't equal 0. It could equal 1, it could equal less than 1. The graph of the quadratic function is a parabola. So there's a lot of terminology that we kind of talked about last time. And if you recall, a parabola can open upward, or a parabola can open downward. Okay? So the point at which the graph changes between decreasing and increasing is called the vertex. So the point of change when you're looking at your parabola, in my first one, the point of change is roughly there. And for the second, the point of change is roughly there. So as you can see, for the first one, which is on this left, it was going down, and then it reached a certain point where it stopped, and then it continued upward. Okay? For the other equation, it was heading upward. It reached a plateau, which was at my vertex, and then all of a sudden it was heading downward. So it's a place where a point where it basically changes position. Since this one, this point or this vertex is at the lowest point, that's called my minimum. And since this vertex is the highest point, that's called my maximum. Okay? The way that this graph is, the one that has the minimum, it looks like a cup. Okay, so if I was looking at a little teacup with a little saucer, it looks like a cup. So you're holding that cup upward in order for information to be poured in. So the way I would say, I would describe this graph is held upward. And this other one, obviously the teacup is upside down this time. So I can't put information in, instead it's pouring information out. So I would say that this one is downward. Okay, so the opening is facing downward, whereas the other one with the cup, it's opening upward. So one of the things we wanted to do was refresh your memory on the difference between linear and quadratic functions. So one of the following tables below represents a linear function, while the other one shows a quadratic function. Without graphing it, which is linear and which is quadratic? And what explanation do you have for your answer? So first off, I'm looking at the x values, and both of the x values are exactly the same. Whoa, what just happened here? Everything's acting kind of funky. So my x values are exactly the same, so we don't have to worry too much about the x values because they're all increasing by 1. But let's take a look at our y values. If we look at our y values, if I take the difference of these y values here, I would have what? -2? But it's actually going up by 2, right? But if I take the difference over here, I don't have that same answer. So I get 2, 6, 10, and 4, which as the table on the left-hand side, once I do the difference of them, or once I see the pattern, I see right away that I have a constant answer of 2. So I'm always going up 2 every time my x increases by 1. Therefore, That table is representing a linear. Linears always have constants in the first difference. Whereas in the second one, in the first difference, I get 2, I get 6, I get 10, I get 14. So in order for me to figure out that it's quadratic, I need to take the difference of the difference. So the difference of this is 4, difference of that is 4, and the difference of 10 and 14 is also 4. So my second difference, that's where I see my constant. When you see your constant in the second set of difference, that's when you know when you have a quadratic function. Sorry, that's supposed to be an R. Okay? So the difference between linear and quadratic is linear, you're going to get your constant right off the first set of difference. Quadratic, you're going to see your constants in the second set of differences. Think about it. When you see an equation that's quadratic, right away, I have my highest degree, which is 2. So that 2 can refer to how many times I have to do the subtraction in order to figure out what my constant will be. So right now, my constant is going to be 4. So far, I have a quadratic function. So one little activity that we did, I had a piece of paper with 10 different tables on it. I split it up amongst each row. So each row had to do 10, no, I lied. Each row had to do like 2 tables. So I have 5 rows, so each row did 2, so it didn't have to take too long. And I'm going to try to put that on the website, just a little extra activity, just to practice up the difference between linear, quadratic, and neither. So we went a little bit further. But this time we're looking at quadratic functions graphically. Okay? How can we find an equation that's going to represent our quadratic functions? So one of the things that we mentioned is that we have what's called a parent function. So a parent function is basically where my starting, the originator. Okay? Think just like a parent. You came from someone. Okay? So a family of curves is a group of curves that are derived from performing transformations on a parent function. So a parent function for a quadratic equation or quadratic function is y equals x squared. So we basically put all this information in our graphing calculator. So for A, we had y equals x squared, and we just put that into the calculator, and that was our starting point. Then we proceeded to put the other equations in. Y equals 0.2x squared, y equals 4x squared, and y equals negative 0.5x squared. And we just basically traced each of the graphs, as you can see below. So the difference between A and B is that B was a little bit wider. Okay, it's almost like someone basically took the ends of the parabola and went 2 opposite ways with it. The difference between A and C is that it was a little more narrow. So almost like someone took the ends of the parabola and pushed in towards our y-intercept. And the difference between A and D is it flipped or it reflected over the x-axis. So now instead of it opening upward, it's opening downward. And being that we have a 0.5, it was kind of slightly open, almost like with graph letter B. So the follow-up questions was the first 3 graphs open up, but the 4th opens down. So I got my up and down. What is the difference? It's supposed to be difference. In the equation of the 4th function that would have caused this change, it would have been my negative sign coefficient. Okay, so what caused that flip? If you notice, all of the first ones, A, B, C, were positive coefficients. My coefficients is 1, 0.2, and 4. And the last one had a negative zero point 0.5. So that negative caused that flip or that reflection over the x-axis. All four graphs have the same vertex at 0, 0. If the coefficient of x squared is positive, it's going to open up. And if it's negative, it's going to open down. So as the coefficient of x becomes greater than 1, so that's key. So anytime it's something that's greater than 1, 2, 5, 5.7, 7.8, okay? The graph gotten wider or narrower. It's gotten narrower. So look at what we had up here. We had my y equals 4x. Notice it was my 4 is greater than 1, so that's why it got really narrow. When the coefficient is between 0 and 1, the graph got wider, okay? So if you notice, for graph B and graph D, we had 0.2 and we had 0.5. Even though that 0.5 was negative, the negative is causing the flip. That 0.5 is causing that graph to get wider. So while the graph visibly looks wider or narrower than the parent function, the coefficient of x squared reflects the dilation of the graph. If the graph has become wider, we say it's compressed. Think about it. When you step on a soda can, what happens to it? You would say, well, I'm pressing down so it gets smaller. True. But what happens? Isn't that air that's within that can trying to get out? Doesn't that can kind of expand outward? As you compress, all that items or the air is trying to get out, so it's expanding out of the material. So if you think, when it's compressed, it's getting wider. Whereas narrower, we would say it's stretched. So think about it. If I'm trying to get real small, don't we breathe in and then try to squeeze ourselves in there? We try to bring ourselves a little more narrow or smaller when we're trying to squeeze into a small space. So when you're getting narrower, you're getting stretched. And that's going to be our larger numbers. So our larger numbers is when you're getting stretched. Our smaller numbers is when we're compressed. So for example, we have f of x, and this is supposed to be equals. I don't know what's going on with my equal signs. So f of x equals 7x squared. So f of x means function of x. And you're generally going to see that, especially when you get into algebra 2. So f of x is just another name for the function y. Y is just a function of x. As we all know that y depends on x. So that's why they put it into this terminology of saying f of x. So if my f of x equals 7x squared, 7 is larger than 1. So since 7 is larger than 1, it should be stretched. Since that 7 is positive, that means it's going to open up. But compared to our original graph, it's not moving. All it is just getting stretched and it's opening upwards. So that means my vertex is going to be exactly the same, which is at 0, 0. For B, we have negative 0.3x squared. So we have 0.3, which is between 0 and 1. So that means we're dealing with it's compressed. Since it's negative, we're looking at going down. And its vertex is also 0, 0. For C, again, there should be an equal sign there. And we have negative 10x squared. So 10 is greater than 1, so we're dealing with stretched. It's negative, so we're looking down. And its vertex is also 0, 0. So you're probably saying, So that means my vertex is always going to be 0, 0? Not always. In this case, yes, but I'm trying to break this stuff down to you step by step. So for D, 3.5, 3.5 is greater than 1, so that means it's stretched. It's positive, so it's upward, and it has a vertex of 0, 0. So that's that first part. So right now, it looks like the sign is telling me it's opening up or down. The numbers are telling me if it's going to be compressed or stretched. So here we go. Remember that a parabola is a graph of a quadratic function. It is a U-shaped curve that either opens up or down, and the maximum or minimum point is called the vertex. Up until this point, you have learned that the coefficient of x squared terms affects the dilation. So it affects if it compresses or if it stretches. So now we're going to learn how it's going to move, how that vertex moves, either left or right, or up or down. So what I would like to do is put that parent function in again, our y equals in the graphing calculator. So you have y equals x squared. And then the second equation, I'm going to put in x squared plus 2. So I'm looking at this part right here. So when I put that in, I notice that my vertex or my actual parabola moves up 2 units to the point 0, 2. So it's almost like that point 2 just raised it up along the y-axis. So if I look at the next one, I have x squared plus 5. This time, the parabola moved up 5 units to this point 0, 5. And last one, x squared plus 8, the parabola moved up 8 units to the point 0, 0.08. That's not supposed to be there. Okay? So what can we say is the pattern so far? So far, it seems like the pattern is when I have a plus sign here, I'm moving up. And this is telling me how many units. So let's look at the next page. So we have x squared plus 3. So that means the parabola moved up 3 units. So now my point is 0, 3. So now I have x squared minus 5. So that means I moved down 5 units. So my point is now 0, -5. And the next one, I'm going to move down 6 units. So we have 0, -6. So right now I can say if it's positive, it's moving up. If it's a minus, it's moving down. Okay, seems easy enough. Now let's look at the next part. What's different besides my missing equal signs? But what's different is we got parentheses this time. So if I put in this function, x plus 2, put parentheses around that expression, and square it, what would happen? If I looked at it, I would say, oh, it's probably going to move left or right because that's what the options that they're giving me, right? And since it's plus, I would assume that it's going to go to the right because all the positive numbers are there. Wrong. In this case, when you put it in, you're actually going to see your equation here. It's going to shift 2 places, 2 units to the left. You're like, how does that make sense? So again, I have x plus 5 squared. So since it's plus, I should be moving to the left 5 units, which is causing my point to be negative 5, 0. And for number 3, I'm moving to the left 8 units, which is causing my point to be negative 8, 0. And again, it's supposed to be an equal sign. And this expression, x plus 3 squared, is telling me I'm moving to the left 3 units, which is causing my vertex to be negative 3, 0. So what do you think will happen if we have minus signs inside the parenthesis? If we have minus signs inside the parenthesis, that means we're going to go to the right. So if we go to the right 5 units, we have our vertex at 5, 0. Again, equal signs. So for this one, I'm supposed to go to the right 6 units. So that means my point is 6, 0, because I'm just going along the x-axis. So you're probably saying to yourself, well, if it's positive, I'm going to the left, and when it's negative, I'm going to the right. I'm going to reveal how they came up with this, okay? So just trust me. So if it's positive and it's inside parentheses, that's key, you're going to the left how many units? If it's negative and it's inside the parentheses, we're going to the right how many units? If it's not inside the parenthesis and it's positive, we're going up, just like this right here. And if it's not in the parenthesis and it's a minus, we're going down, okay? Inside parenthesis, you're going left or right. Not inside the parenthesis at the end, we're going up or down. There is another name, before I go into the mixture of this, for, let's say, this negative 5. Remember back when we did linear equations? That negative 5 or that negative 6 represents your y-intercept. Isn't that a point that's on the y-axis? Yes, it is. Okay? So it's kind of like taking a lot of stuff that we learned linear functions and we're putting a twist on it because instead of a straight line, we're dealing with a parabola. Okay? So a lot of the stuff that we're learning comes full circle. So now, let's kind of mix things up a little bit. So right here, again, is the equal sign. So we have the function of x equals x plus 5 squared plus 7. So they're asking, the vertex of the parabola moves left or right. So if we're looking at left or right, we're looking inside the parenthesis. Since it's a plus sign, I know you want to say right, but you're actually moving to the left 5 units. And is it up or down 7 units? Well, let's look at where the 7 is. There's a plus sign, so that means we're moving up 7 units. So since we moved to the left 5, remember we started at 0, 0. We moved to the left 5 units, so that's negative 5. Then we went up 7 units, which is positive 7. That's why my vertex is negative 5, 7. Looking at number 2, we have x minus 2 squared plus 3. So, are we moving left or right? We're moving to the right 2 units, because that's what's telling me right there. And then I'm moving up 3 units. So that means my point is 2, 3. 2, 3. Number 3 is actually continuing on the next page. So what I did was just rewrote it on the top, which is f of x equals the difference of x and 4 squared minus 6. So we're looking at the units. So we've got a negative 4, so I'm going to the right 4 units. And then I'm going with the negative 6. That means I'm going down 6 units. So if I went to the right, that means it's positive 4, because that's what my positive numbers are. And then I went down, so that's a negative 6. So my vertex is now 4, negative 6. So it seems like this number and this number is helping me find my vertex. Okay? What we've just done, we worked on what's called vertex form. Okay? Vertex form is y equals a times x minus h squared plus k. A is like our leading coefficient. Okay? The sign of A is going to determine whether it opens up or down. Okay? Whether our parabola opens up or down. The value of A, so the actual number of A, is going to tell me if we're dealing with compressed or stretched. Okay? And you can deduct that the value of h, which is inside the parenthesis, the vertex is going to go from left to right, or left or right, and the value of k, which is outside the parenthesis, see it? That means we're going either up or down. Okay? So the number that's going to be in front of your parenthesis, it's going to tell you either you're going to compress or stretch. The sign of that number is going to tell you either your parabola is going to open up or down. The number that's representing h in that vertex form is going to tell you, because it's inside the parenthesis, either you're going left or right, and that's actually going to be the x of your vertex. So if I wrote it out like this, h and k is the same as me saying x and y, okay? So if you notice here, for our example, we had a negative 4. We had to go to the right 4. Isn't that the 4 or the x in my vertex? Then we had a negative 6 because we had to go down 6. Isn't that the y value of my vertex? Okay? So it's exactly the same. And if you're not sure, it's written right here for you. Okay? Be cautious of this. Watch that sign of the h value. Which way did you go? So what I had students do to finish up was to complete this table. If they didn't complete it in class, they completed it for homework. My 2A class, they're actually going to complete the rest of that in class on Friday the 20th, since I have them all day, because we had a weird schedule on that day. But let me go through it step by step. The only thing that I wish right now, let me bring my plus sign over a little bit. The only thing that I wish at this point in time is for you to tell me, is the parabola going to open upwards or downwards? Are we going to have a max or a min? What is my vertex? And is it stretched or compressed? So quickly, as a refresher, if you had a parabola that opens upwards, okay, you're going to have that lowest point. So that lowest point is going to be my minimum. If you have a parabola that opens downwards, you're going to have your highest point. So that's going to be your maximum or your max. So let's see if we can go through this. So looking at number 1 gives me an example. We have negative 2 times x minus 3 squared minus 1. So how do I know if it opens up or down? I'm looking at the negative that's in front of that 2. So it's going to be opening downward since it's negative. So if it's opening downward, that means I'm going to have a high point or a maximum. And then my vertex, that's when I'm going to look at my h and my k. So we started at 0, 0. The negative 3 is telling me I'm moving to the right 3 places. That's where this 3 came from. Then I'm looking at this negative 1. That's telling me I'm going down 1 place. That's where this negative 1 came from. Now, the 2, which is my A value, that's going to help me figure out if it's going to be stretched or compressed. So 2 is greater than 1. Like we said before, any number greater than 1, it's going to be stretched. So that's why we have stretched in that column. Okay? So let's try a couple, and then we're going to compare answers the next time we do this. So for number 2, we have x minus 1 squared. So we don't have a number other than 1 in front of that parenthesis. So it's positive. So right now it's opening upward. So if it's opening upward, that means I have a minimum or a min. Now let's look at the vertex. All this did was go 1 unit to the right-hand side. So that means my x value in my vertex is going to be a positive 1. Did it go up or down? I don't have a y-intercept there. So that means it didn't. So I put a 0 in. So my vertex is 1, 0. So do I have an A value, which is right here? Do I have an A value greater than 1? No, it's 1. Do I have an A value that's in between 0 and 1? So is it a decimal? No, it's 1. So that means I don't have a stretch nor a compress to put in. So I can just leave it blank. So that is an option. For number 3, is it opening up or down? So since this 3 right here is positive, it's opening up. And to jump ahead, if it's opening up, that means it's a minimum. Is it stretched or compressed? Since it's greater than 1, that means it's stretched. And now what's my vertex? Inside this parenthesis, I have a plus 4. That means I had to move 4 units to the left. So that will make it a negative 4. And then I had to go down 2 units. So it'll be a negative 2. So my vertex is negative 4, negative 2. Okay, for number 4. My A value would have been there. So there's nothing there, but there's understood to be a 1 there. Every time you don't see a number there, 1 is understood to be there. So right away, that'll be positive, so it's opening upward. Then I have a minimum. Should have made that a little bit smaller. Okay, so since I don't have a number there, that means it's 1. That means I don't have to put anything down. But now what is my vertex? Inside the parenthesis, I don't really have a plus or a minus, so that means there's got to be 0. And then from there, I just went down 2. So my vertex would be 0, -2. For number 5, let me switch pens. We have a -1, so that means instead of up, it's going down, and instead of a min, I have a max. So if it's -1, again, it's not over 1, it's not in between 0 and 1, so we just leave it alone. But my vertex is just simply 0, comma, +7, because I don't have parentheses there that's telling me left or right. The only thing I have is my +7. So it is 0, 7. Number 6. Since my 0.5 is positive, I'm going up. That means I have a min. And since it's 0.5, this will be compressed. Because remember, if it's compressed, it's between 0 and 1. Now, what's my ordered pair? Inside the parenthesis, I have a -1. So that means I had to go to the right one. Okay? So I went to the right one, and then my y-intercept is telling me +4, so it's 1, 4. For number 7, since my 6 is positive, I'm going up. And if it's opening up, I have a min. And since 6 is greater, so it should be stretched, greater than 1. Oops. I don't have parentheses to tell me left or right. I don't have anything outside to tell me up or down. So that means my vertex is at 0, 0. Starting to get the idea? Okay. So if you want, you can stop the tape. You can, or recording I should say. Try 8 and 9 and 10. We can compare answers, and then we'll see how things go. Or you can just wait until I do the whole entire thing like everybody else does. So we have a negative, so that means it's going down. Since it's going down, I have a maximum point. Since it's 0.9, it should be compressed. And I have something inside the parentheses, so it's a -5, so that means it's a +5. And here is a -10, so that means my y-intercept is -10. And there's my point. In front here, there's nothing there but 1, so it's going upwards. I have a min. Nothing with the compress and the stretch. Looking inside the parentheses is a -9, so it's a +9. But is there anything outside the parentheses? No. So it'll just be 0. And last but not least, we have a +4 here. So that means it's upwards. That means I have a min. Since it's 4, it's greater than 1, so it is stretched. And my vertex, -8 is in here, so that means I'm going to the right 8 units. And this -3 right here means I'm going down 3. So your chart should look like this. Okay? So it just really give you the practice of, yes, you can put this in the graphing calculator, keep your parent function, which is that x squared where it is, and compare it with the remaining 10. Or you can just follow along. You can look at what the equation is giving you, and then just look. Okay, do I have a leading coefficient? Say for number 1, I had -2. For number 3, I had 3. For number 6, I had 0.5. For 7, I had 6. For 5, I had a -1. Okay? That's going to tell me, the signs of it's going to tell me if it's opening up or down. The number itself, if it's greater than 1, it's stretched. If it's between 0 and 1, it's compressed. Then you can figure out if it's opening up. Obviously, we have a minimum point that's telling me to make my change. If it's opening down, then I have a maximum point that's telling me to make my change. And then I'm looking to see what's inside the parenthesis. Remember, inside the parenthesis is telling me left or right. Outside the parenthesis, towards the end, my y-intercept is telling me up or down. And that's how we'll be able to get my vertex. Okay, so we're going to do a little more practice with this, a little more structure, and a little more practice with graphing. All right, so that's all we basically did for those 4 days. Going to do a little more practice with it before we start taking assessment, which will be sometime the week of the 23rd. Okay, definitely want to get some kind of assessment in before you guys go on a 3-day holiday, which will be on the 30th, Memorial Day. Okay, if any questions and concerns, please come.